A little bit more about this beast. As I said, it does work. There's a trouble I'll show shortly. It's nice that it has all the knobs on it. These two, while not cracked, are very loose. In fact, if you tip this radio up, these just drop off. So that's a minor thing. Needs to be addressed. I know these shafts, they're knurled, splined, I guess is more proper. There's a slot, and there's always a temptation. Just I'll stick a flat blade screwdriver in there and, you know, spread those two halves of this shaft apart to more tightly fit the knob. Don't do that. How many of these types of shafts I've seen where one half of it is broken off because somebody attempted to do that? Don't do it. It's fine the way it is. What I would do in a situation like this is just, when I'm finally ready, you know, it's all buttoned up and working, I'll put a tiny little dab of RTV on there, silicone rubber, not much. Don't, you know, slather it all over the place, just a tiny little dab of it on one side of the shaft, and then put the knob on. And that's just enough to keep it from falling off and being sloppy. At the same time, if later you need to pull the chassis to do some work on it, it's no big deal to pull the knob off. Do not use epoxy. Don't shove aluminum foil around it. Don't strings in. No, don't do it. It's a dab of RTV, silicone rubber. Cheap enough. Works very well, and it won't screw anything up. So there's that. I'm not going to clean any of this. I had when I originally got this radio, gosh, I think 10 years ago, and it's been kept in good storage, so it's still clean. So I'm not going to mess with any of that. Just going to fix the radio. Now, what's wrong with it? Before I power this up, just to give an idea, a baseline of what radio reception is normally like here during the day. This is one I repaired recently. Did not do a full restore on it, but just enough to get it working. AM broadcast band.
For treason. So what would be treason? Down on the JFX. He doesn't either, but
Mel Anthony. All right, Melvin.
For the run stopper portion of that, they haven't really had anyone.
So you get the idea. There's no dearth of signal here. Plenty of it. Well, and this is a particularly sensitive radio. But even these AA5s, if they're working right, are pretty close to that performance. I've got all noise sources off, electrical noise sources. In fact, the camera right now is running on batteries because the power supply I have here is a switcher and it just pollutes everything. Yeah, you try dialing across the AM band, it's wee 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 wee, and that's, can't use that. Hopefully the batteries will hold up long enough for me to get this segment completed. So what's it do? Turn the Variac on. I'm just going to go the full Monty, 120 volts, and switch it on. And volume up just a little. Moment for the tubes to come up. some life. Right away, there's trouble. Hear that? You weren't getting any of that through that other radio. It's not atmospherics. It's internal. Now, do some tuning and see what she does. Yeah. So there sometimes in its current condition there are places where at times you can actually pull in a station, works just fine, and then you get this. That's not radio. That is a problem that these radios of this era had fairly regularly, especially when they're as old as this one is now. As I've said, I replaced the paper capacitors in this thing, not the electrolytic. If it were the electrolytic, one of two things: it would either be shorted and nothing would happen but to blow out the rectifier tube, or if it were just dried out and open, there'd be a lot of hum. There's no hum at all in this radio. Just this static. What's going on? I'm going to turn this off. What's going on with that? The IF cans in this thing, the coils, which are in little aluminum cans. Inside of those, of course, there's a couple of coils, they're transformers, and there's a primary and a secondary, and both are tuned. Integrated in with that are two capacitors, normally, and in this case, that's the case. Two IF cans with coils in them, transformers. And to save expenses, they integrated the capacitors, there's two of them, into the base of the coil, the part that supports the coil form. It's a form tube with two coils of wire wound on it. And rather than use discrete capacitor components and have them soldered on, which would have been much better, what they did was they used a mica sheet, and they somehow deposited metallization on that sheet, and that single sheet is actually making up both capacitors, which is fine, except that because of where the coils and these capacitors are in the circuit, one of those capacitors is at the voltage level essentially of both sides of it is at ground, or in this case connected to the chassis. Don't get into the hot chassis business, but call the chassis ground. So one of those is connected to the chassis essentially, so it has about 0 volts on it. The other capacitor in that coil has B plus on it, in this case about 130 volts DC. And under normal circumstances, that's fine. Those two capacitors on this common mica sheet are separate enough where they don't interact with each other. Well, trouble. Over time, humidity, corrosion, contamination by dust, cigarette smoke, or whatever, infiltrates those cans, those IF cans with the coils in them, and it causes a leakage path, an electrical leakage path between the two separate, electrically separated capacitors. Well, they need to be electrically separated. One needs to have 0 volts on it, The other one needs to have 130 volts on it, or thereabouts. And what happens is a leakage path is established along the surface of this capacitor, or between these two capacitors. One of them's connected across the primary coil in this transformer can, and the other one's connected across the secondary coil. And those are there to bring it, to bring it into resonance. So what's going on is a leakage between these two capacitors in one or the other or both of the IF transformer cans in this radio. And that's what that noise is all about. And when that happens, it disturbs the bias of the tubes, grids, and nothing's going to work right. And even if it does, it'll be sporadic and noisy. So what do you do? What do you do? From a radio wizard of old, who in fact clued me into this particular trouble many years ago, suggested to take the coils, take the cans apart, remove the coil, take that old mica sheet, quote unquote, capacitors out of it, and solder in discrete units, discrete little capacitors. They're quite small, they'd fit right in. And then you could put the can back together and essentially make it work just great. And unless somebody pulled the can apart again, would never know that that modification was done. So that's pretty much what I'm going to do here. So you try to look and find out what the value of those capacitors is. For GE, typically they're 130 picofarad. It may vary. I would suggest, if you're going to go through this, experimentally, take the coil apart, take the can open, take the coil apart. Don't disconnect the coil or anything, but get that mica sheet out of there. You'll know, if you're into this stuff, you'll be able to recognize what it is you're looking at once you get in there. There are a couple of vids on YouTube you can check where other guys demonstrate how, details about how that's done. I'm not going to repeat it here, most likely. So take that cap out, wire the can back in, just tack it in, and start with 130 picofarad caps. I would recommend silver mica, something that's temperature stable. Silver micas are good. Those dipped brown ones work wonderfully, although they're not cheap. Another choice for those, a good choice for those, would be COG discs. COG disc capacitors, also known as NPO disc capacitors. They have a very little change in value over temperature. Another good choice are the polystyrene ones. I've had good luck with those. So tack them on, see if the coil will tune. It helps to have a generator, for the IF frequency. If you don't, you might have some luck doing it, just doing one coil at a time, and just tuning into a strong station and peaking it that way. That can work. These are not difficult to peak. It's only got two coils, and there are two adjustments in each. The primary and the secondary both have slugs that are adjustable to tune it. So for these GEs, and probably some of the others, if it's got a 455 kilohertz IF frequency, which is typical radios of this era in the early 50s or so. It's got 50 C5, 35 W4, 12 BE6, 12 BA6 tubes in it. The coils are almost identical, and you can interchange them from one brand of radio to the next. I've done it with mixed success. I do want to keep the original coils in this guy. I'm sure that the coils themselves are not bad. It's those daggone capacitors in them that are the trouble. So that's the deal, and it's a little tedious. I hate having to remove coils because you got unsoldered wire, old brittle, stiff wires from very fragile connections on these coils. Mechanically, they're not difficult to get out. There's little spring clips on them that you can release and pull it out, pull the cans out. And of course, you know, once you get into the can, you got to be super careful. Those wires are thin. If you got the moxie to open one of those cans up, you probably are already aware just how delicate some of that stuff can be, especially at the age. With any luck, I'll get this working. I might take some vid of the process of removing the cans, maybe opening them, maybe even doing some of the work, depending on time constraints and how long of a series of vids I'm willing to do on this beast. See ya.